Oke, Assalamualaikum warahmatullahi wabarakatuh. My name is Egga Bahartyan, a student of Magister Teknologi Informasi program at Universitas Gadjah Mada, and I will be presenting my assignment, which is AWS Cloud Deployment Cost Estimation with Workload Profile. Here's the objective that I will be estimating the monthly AWS cost of deploying web application based on clearly defined workload. Here's the scenario that my company is launching a new online platform. So they are responsible to estimate the monthly AWS cost of running the system. There's some workload and these are required AWS service, and I will be choosing one of these four, and here's some tasks and some deliverable. So let's get to my presentation. I just made this interactive presentation. So let's get started. So the objective is, as I said before, that I need to simulate using AWS pricing calculator. And for this scenario, that my company, and assume that my company is in Indonesia, uh, will launch a new online platform, and I will estimate the monthly AWS cost of running the system. Assume that my company is in Indonesia, so that I will choose the Jakarta region. And for the workload profile, daily active user is 5,000 and peak concurrent users is 300 and monthly active users is 20,000. And for the traffic and requests, average request per user per day is around 40 and peak request per second is 120. Average response size is 200 kilobytes and static assets from S3 is 30% of traffics, while the remaining 70% are dynamic requests, and that will be handled by our EC2 instances. And for the RDS database size would be 80 gigabytes and have daily growth of 1 gigabyte per day, daily reads 2 million, and daily writes is 500,000. And for the backup retention, 7 days. And next is S3 storage, where static asset is 150 gigabytes, where the monthly uploads will be 20 gigabytes and monthly downloads will be 500 gigabytes. And for networking and data transfer from EC2 to internet outbound, I assume that will be 300 gigabytes per month, and S3 to internet downloads that will be 500 gigabytes per month, and internet to EC2 inbound that will be 150 gigabytes per month. And for S3 to EC to internal, that will be 200 gigabytes per month. And EC2 to radius traffic, let's assume that will be 1 terabyte per month. And here's the required AWS services. First is Amazon EC2, and we will use 1 to 2 Linux instances, and Amazon RDS, Amazon S3 for storage and data transfer. And the last is we are going to pick optional and at least one. So I will be choosing elastic load balancer. Okay, now is region selection and exit structure methodology. So because our target demographic uh, our company is in Indonesia, so that I will be choosing this like I have explained before. Uh, because this will minimize the latency for Indonesian users and meeting data sovereignty requirements. And for the database scaling from initial 80 gigabytes plus 1 times 30 days. So that will be 80 plus 30 gigabytes. That will be 110 gigabytes for minimum proficient storage. And for the throughput, 120 peak requests per second necessitates a multi-instance compute layer with load balancing for high concurrency. And for the data transfer egress is around 300 gigabytes for EC2 plus 500 gigabytes for S3, and that will be equal 800 gigabytes total amount outbound. And for the architecture, we will use the multi-tier high availability approach to eliminate single point of failure. So, this we will be estimate this architecture to EC2 instances, one load balancer, and users from the internet. So let's get to the AWS calculator. Let's open calculator.aws. Maybe we will going to use this. And we are going to use public pricing calculator without signing in. Okay, now let's configure the computer here. So first we are going to search using keyword EC2 and configure this. Let's wait, yeah, it's loading. Okay, it's done. Now first for the tenancy, let's set to shared instance. This means our virtual machines run our physical hardware and it is shared with other AWS customer via hypervisor. And we are going to choose a Linux operating system. And for the workload, we are going to choose constant usage. Constant usage means our instances run continuously 24/7 at steady level. So this is what we need because a production web platform must be available at all times to serve users. regardless the traffic volume. And for the can you click? So this has some explanation that the spike traffic is best for usage pattern that big once a day. This is suitable for scenario where, for example, you need to run server job at midnight or have a morning spike. See, like I said before, this is best for website running process for a website or running process in the background. And weekly spike traffic is uh, best for blogs that post once a week and weekly television shows. Monthly spike the same, but the difference is just it's monthly. That's all. So we will choose constant usage. And now for the number of instances, let's set to two instances. We deploy two instances uh, because it's for high availability. Because if one instance fails or maybe need maintenance, the other continues serving serve the web, the traffic, and also this allows us to distribute the load like with 120 peak requests per second so that each instant will handle roughly around 60. So that will prevent any single point of failure. Now, for the instant type, for around the workload around this specification 2000 monthly active user. Um, we just let's just speak for two virtual CPUs and A4. So let's just pick a medium. Let's just pick T3 medium. So the T3 family is known as burstable instant type. It means that it provides a baseline CPU performance of 20% with the ability to burst up to 100% when needed. Using CPU credit system, this is ideal for web application where CPU usage is variable, like mostly idle or moderate or with spikes during page renders or peak traffic. Uh, I think this is the most fit using T3 family. And next for the payment option, for now we will choose the on demand. Um, on demand means we pay by hour with no upfront commitment. And this is the most flexible but most expensive pricing model. So we start with on demand to establish our baseline usage patterns. And for the usage, let's configure to 100% utilization per month. Because we need to set 100 because we are going to make a web platform, web application, and it must be available for 20 hours a day and 7 days a week. Okay, save and add service. Okay, and next is for the we already configured the EC2, and next is load balancer. Let's find using keyword load balancing. So this elastic load balancing. Let's configure this. So the region is still Asia Pacific Jakarta, and this load balancing. Here's some explanation. That we can choose the appropriate load balancer based on our application needs. So there are four types of load balancer, and the first is application load balancer. It operates at layer 7, HTTP, HTTPS, and this is what we will use because it understands HTTP. It can route requests based on URL path and also supports WebSocket like a website nowadays, and integrates with web application firewall for security. And this is purposely built for web application traffic. And for the network load balancer, it operates at layer 4, TCP, UDP, and this is best for extreme performance needs like millions of requests per second or non-HTTP protocol like gaming servers or IoT. And for the gateway load balancers, it operates at layer 3. This designed for deploying and managing third-party virtual network appliances such as firewalls, IDS, and deep packet inspection tools. This is not relevant to our web application. It's for network security infrastructure, not application traffic distribution. And the last one is classic load balancer. This is the original AWS load balancer, but now it's considered as legacy. Uh, it it says that it offer basic layer 4 and layer 7 balancing, but lacks modern feature like path-based routing, host-based routing, and native HTTP to support. And AWS recommends migrating away from Classic. So we are not going to use this. And for the application load balancer feature, we are going to choose load balancer in AWS regions. It means the application load balancer is deployed within our Jakarta region. And next is number of application load balancer. Uh, it says the single ALB can handle thousands of requests per second and distribute them across multiple target instances. It says that our peak concurrent user is our peak concurrent user is 100 and peak request per second is 120. So that's just within uh capacity of one LB. It says it can handle thousands of requests per second. So one is enough. And next is the load balancers, capacity units, LCU. So a little bit explanation that LCU measure for dimensions, and we are going to be built for whichever dimension that has the highest usage. So for this, process byte lambda function or target. So because we are not uh, going to use lambda and our architecture routes all traffic to EC2 like this. So we don't need. Let's put it in 0. And this process byte EC2 instant. Uh, let's count a bit for this. Let's do some calculation so that ALB only process traffic destined to our EC2 instances, not direct S3 traffic. So let's say we count 150 gigabytes inbound from internet plus 300 gigabytes outbound from EC2 to internet. So that will be 300 plus 150. That will be 450 gigabytes per month uh, flowing through the ALB. And if divided by 730 hours for a month, that equals approximately 0.62 gigabytes per hour. So that let's round up 0.62 gigabytes and round it up to 1 gigabyte per hour. And for the average number, so the from this workload profile that 5,000 daily active users, let's say that I generate sessions throughout the day. Assume that an average session length of 10 minutes, user making multiple requests per session, and traffic distribute over 16 active hours. So we get approximately 5,000 sessions divided by 16 times 3,600 seconds. And that will be 0.086, and we round it up to 0.09 new connection per second average. However, with HTTP keep alive timeout and connection reestablishment, a value of 10 provides a safe buffer. So let's put to 10 per second. So the hopefully that will be safe. And next is average connection duration for each connection. Um, so let's say the last 1 minute or 60 seconds. And average number of requests per second per ALB. um, while our peak request per second is 100 requests. So the constant daily average is more, it's much lower. So 5,000 daily active user times 40 requests per user per day. That will be 200,000 daily requests and spread over 16 active hours to 200,000 divided by 16 times 3,600. That will be around 3.5 requests per second. So let's just round up to 5. And the average number of rule evaluation per request, so that its request is evaluated against the LB routing rules. Let's say the default rule plus view path based routing rules for the application, like slash API slash something, or slash static slash something, or slash half, something like that. The result is roughly 10 rule evaluation per request. And I guess this is assume that it's the appropriate for standard web application. Let's put it 10 and save and add service. Okay, and next we are going to the database. Let's find our DS. Peak because this doesn't specify what the database, but let's assume that we are going to use free but currently popular relation database. We are going to choose PostgreSQL. Why we choose this? Because PostgreSQL is fully open source. It means the zero licensing fees, unlike Oracle or SQL Server, which add substantial per hour charge. And PostgreSQL multi-version concurrency control handler can handle around 500,000 daily writes. And yeah, this is assume that this is the best. No number of nodes. One. We only need one node. Mm, and then the instant type. Hmm. Let's just use a EV3 medium. So my consideration is that let's say uh, for the RDS database, a 2 million daily reads and 500,000 daily writes translate to roughly uh, 29 queries per second on average. So this instant type is enough for this. So they are going to choose this. And the T3 burstable family is appropriate because database CPU usage is typically spiky and yeah, mostly moderate with bursts during complex query or batch operation or sometimes idle. So this kind of CPU uh, might be the best option, and we avoid large with 8 GB memory for now. Because our 80 gigabyte database working set is likely much smaller than full data set, and 4 gigabytes is sufficient for hot data caching. Next is this field for the utilization. Mm, let's set 100% per month. And for the deployment option, we will use multi-availability zone. And actually, this is a critical reliability decision. Multi-AZ creates a synchronous standby replica of our database in a physically spared availability zone within Jakarta region. This means that every write to the primary database is synchronously replicated to the standby before being acknowledged. If memory fails due to hardware issues, network problems, or AZ outage, RDS automatically perform a failover to the standby, typically within 60 to 120 seconds. And also, this costs approximately double the single instant price, but it eliminates the risk of data loss and extended downtime. And that is non-negotiable for production platform. And for the proxy, there's no explanation for this. And I guess we don't need proxy because it directly connected to the web application instance. And for the storage, let's use this. Start amount is wait, let's make uh CP3. So the difference between general purpose 2 and 3 is the GP2 ties IOPS linearly to storage size at 3 IOPS per gigabyte. So the 110 gigabytes will only give 330 IOPS, but GP3 provides a free baseline of 2000 IOPS and 125 megabytes per second throughput, regardless of volume size, which is 9 times more IOPS than GP2, which give us at same sort size. And GP3 is also approximately 20% cheaper per gigabyte than GP2. For our workload of 29 queries per second, I generated a perhaps 100 to 200 IOPS on average. And the GPT baseline of GPT-3 baseline of 3000 IOPS is more than enough. So we are going to choose this. And for the storage amount, like we already count that we start with 80 gigabyte database with one 1 gigabyte per day, and for 31 days that will 30 31 and sometimes 29 days month, just Just assume the single month will be 30 days, so the 80 plus 30, that will be 110. So let's say 200. And CloudWatch database inside, we don't need this right now. And this, just leave it that way. For the extended support, uh, I just let them know. So there will be no additional cost, and I just save and add surface. Next is the storage. Is the storage. S3 storage. This one. So it says the S3 storage is for static content such as images, videos, CSS, and JavaScript files. So we will use S3 standard, and so we just leave it that way. And for the S3 standard storage, calculate that we have 150 gigabytes of static assets plus 20 gigabytes monthly upload. So there will be 170. Oops, sorry. 100. Yes. 170 gigabytes per month. And let's how we move. We were going to use this, put copy Postgres to S3 standard. The continuous affect moving data to you can so that we can phrase object size. Let's put around four files just for JavaScript for and assume the this Just leave it that way. And for this, put copy post list request to S3 standard. So let's say that 20 gigabytes monthly new upload that must be broken down into individual objects. So that if average uploaded object like image, document, media file is approximately 20 kilobytes, then 20 gigabytes divided to 20 kilobytes, that will be 1 million per request. So that will be, oh, oh, I think this is wrong. So let's put this to 20, 20 kilobytes. And for the get like and other requests, let's say the workload from the workload profile set the 30% of traffic, 30% of traffic is wait, 30 traffic is 30% of 30% of traffic. Uh, so that will be um so assume the workload profile this uh it consists of static asset requests for S3. So the total daily requests are 5,000 daily active users times 40 requests per user, and that would equals 200,000 requests per day. So of these, 30% are S3 requests, and that would be 200,000 times 0.3, that would be equals 60,000 S3 get requests per day. And over a 30 days month, that will be 60,000 times 30 days, and that will be 0.8 million. So let's write this what for the request. 0.8 million. Uh, Assume that this is the number of individual objects retrieved from S3, covering images, CSS stylesheet, JavaScript bundles, font, and other static files. our users download. And for the data returned by S3 Select, um, actually S3 Select is a feature that lets us to run SQL-like queries directly against data stored in S3, like CSV, JSON, or Park Parquet files. And because we are only used for static assets, so we don't need this. And also this one, we don't need this. So save. And the next one is data transfer. So we're going to this one, data transfer. So all the interest will be free. Okay. So a data transfer from, let's see, internet, and we and this for the calculation, this that will be 150. And so the how do we get this number? So the calculation, like assume the HTTP request header and post bodies from 5,000 daily active users, making 40 requests per day with an average request payload of 2 kilobytes. So that will be 5,000 times 40 times 2 kilobytes times 30 days. That will be equals 12 gigabytes. And user file uploads contributing to the 20 gigabytes of new S3 content per month. And that will be, let's say, 20 gigabytes. And there is API calls, form submission, and other user generated data. Let's say approximately 118 gigabyte. So uh, that will be 118 plus 20 plus 12 gigabytes. That approximately that will be 150 a gigabyte per month. And for the intra-region data transfer, uh, that will be this. This is to RDS and S3 to EC2. That will be 1.2 terabyte. 1.2. Oh, So that will be 1,200 gigabytes per month. And next is for outbound data transfer. A Let's say the data transfer to the internet, and this will be 800, 800 gigabytes per month. So this is the configuration of the network. So we already make from the ECS, from the RDS S3 network. So I guess we already finished. So the our estimation is 434.78 US dollar per month. So this is it. And for the recommendation is so this is monthly, and our EC2 instances are running 24/7 on-demand pricing, which is the most expensive option. So by committing to a 1 year compute saving plan with no upfront payment, we can achieve approximately 30% saving on our EC2 bill. If we choose all upfront payment for the 1 year plan, saving increased to approximately 37%. And a saving plan applies automatically to any EC2 usage, regardless of instance family, size, or region, giving us flexible to change instance types as our needs. And the second recommendation is that our single largest expense is the transfer from here, and uh, this the transfer and RDS. So the maybe we could use Amazon Cloud Form. It's like uh content delivery network, so that we can cache our static S3 assets at edge location. So that will be cheaper. And for the last recommendation is the RDS. So that since our database must run 24/7 with multi availability zone, and it's predictable, constant cost. So by purchasing a 1 year RDS reserve instance with no upfront payment, we can reduce the RDS compute cost by approximately 25 to 30%, like just the first recommendation. So we just change to monthly payment to 1 year annually payment. Uh, I guess that's all. So this, in summary, this estimate accounts for all mandatory services which are EC2, RDS, multi availability zones, S3, and data transfer. And plus one optional service is elastic load balancing. And every field value entered into AWS pricing calculator has been uh, derived from workload profile, like 20,000 monthly active user, 5,000 daily active user, and 120 peak requests per second, etc., etc. So the optimization strategies that I have presented hopefully could collectively reduce our monthly bill. And if we do it annually, that will be reduce 20 to 30%. And then this on-demand deployment to committed pricing. Uh, Thank you very much for the attention. Assalamualaikum warahmatullahi wabarakatuh.